So good afternoon and welcome to our webinar on digital twins today. I'm Paul Williams, one of the product managers at Enable My Team, and I'll be presenting alongside my colleague Luke Holbrook, our Chief Operating Officer today. Before we dive into the detail, I'll just do some quick housekeeping. We'll be presenting for around 25 minutes. If you have any questions along the way, please feel free to drop them into the chat. And we'll also aim to leave a few minutes at the end for any further questions. And we'll be recording the webinar, so it will be available online shortly after completion, so you can view it again if wanted. Okay, so let's kick off with the today's topic. So, what is a digital twin? So I expect most of you already know, but just to summarize, a digital twin is beyond just a 3D model, and again, beyond a BIM model, where there may be a lot more associated project data, but usually this is just static and relevant to a specific project phase. So a digital twin itself is a dynamic digital representation of your asset, effectively mirroring your real-world physical asset, involving real-time data and analytics and allowing for operational monitoring, simulation and preventative maintenance. So in terms of Atlas and how Atlas can help you build your digital twin, I'll cover this now with this little pyramid diagram we've got. So our Atlas platform, it's a web-based SaaS platform. At its foundation, it's an asset management platform. So this allowing you to have a simple data structure or through to a highly detailed data structure to form the basis of your digital twin and how your project data should be held. And this can be held or structured so it will contain data from initial design through to operation and maintenance if necessary. Stepping up a level, now we're living in a digital world with so many digital tools used to deliver different information. We need to be able to pull this together and federate this data. So Atlas allows for this through its open API and integration capabilities, meaning that you can involve data inputs from many different sources, such as other platforms you might be using on your project, or down to IoT devices in the field or sensors you've installed on an asset. And all this data can come in and be used within your digital twin. Then we've got the project data level, which is where your project data is managed during the project life cycle. And this is today's focus, where we'll be looking at the three areas of design, survey and geospatial data. Beyond this then, once data's in the system, this is when we can start to work with it and understand it better through using automated processes that we've got built into Atlas. So we've got processes such as data comparison, quality and assurance checks, and other more specific tasks like asset recognition from data sources, and also classification to help bring data in line with your data structure. But these sort of detailed topics we'll cover in future webinars anyway. And then finally at the top, we've got the visualization. So that all the data within Atlas is visualized sort of contextually. So it allows more interrogation into the data and a holistic view of your asset through the digital twin. So now just a reminder again as to what we'll be covering today. So like I mentioned, we'll be focusing on the geospatial data aspects and survey data and how such data sets can be pulled into Atlas and brought together. And so I'll now hand over to Luke, who will cover the first topic of the geospatial data.
That's great. Thank you, Paul. So digital twins aren't unique to just the infrastructure and AEC industries, but the data sets that are used to form the digital twins can be quite unique. So one core data set for the AEC industry is geospatial. So it's really crucial that all of these different data sets coming together are geospatially aligned, certainly when we're dealing with large infrastructure projects. So what actually is geospatial data and GIS systems? Well, most of you will be using them on a nearly daily basis. So Google Maps at its core is a simple GIS platform. It overlays different data sources and has them geospatially aligned so that you can start to federate different pieces of information at certain locations. In the industry, there's a number of GIS tools that many of you and your projects will be familiar with. Esri obviously being a large one. There's open source equivalents as well, such as QGIS. And then EMT Atlas itself has a GIS platform embedded, and it acts as one of our core interfaces into the data and into all of that information that Paul's just highlighted. So we'll show a lot of different examples throughout the course of this webinar, and most of them you will see access through the EMT Atlas interface and GIS platform. So in terms of what is geospatial data, it can literally be any piece of information which has a location-based property to it. So here you're seeing the Open Geography portal just from the government website. This is just through an Esri viewer, as you can see in the corner there. But effectively what we're looking at are local authority boundaries, and these are represented with a simple 2D shapefile, and then the metadata is embedded within that. This is really crucial because it means that we can actually consume this information and ingest it as part of our digital twin. So as well as your project specific information, we can be looking at these open source bits of data, such as local authorities, weather, etc. We can then bring that into the Atlas GIS interface. So again, the navigation is extremely familiar for anyone who's used one of the online map tools. And here we can start to overlay your project specific information. So in this example, we're looking at a railway route. So we can see that we've got some track information and then we've got that localized on the map. And then we can toggle on some additional shapefiles. So here we can see individual point assets, or we can see 2D polygons representing various different asset classes. And we'll go into a bit more detail on what some of those could be later in the webinar. Obviously, because it's a GIS-based layer, you can then toggle on your additional open source data feeds, such as your satellite imagery or your maps. But we can also then start to turn on our actual project data that Paul just mentioned. So, for example, some design and survey information. So these blue polygons you can see represent point cloud boundaries, and we'll go into more detail on those shortly, and other survey data. Now, it's important to notice that geospatial data isn't just 2D. Obviously, we view it on a map because it's a nice way to access that information, but we also want all of our 3D data to be geospatially aligned as well. And the two main sources of geospatial data are going to come from your design and from your survey. So we're going to go into each of those in a lot more detail now. So I'm going to hand back over to Paul to start with the design side of things.
Okay, thanks, Luke. So yeah, in terms of the design data, today we'll be focusing on the sort of 3D BIM models and how these come into Atlas and what we can do with them. So Atlas has its own processing pipeline that can ingest your native model formats such as DGN, DWG, Revit, etc., or open formats like IFC. When the models are uploaded, they're processed into OGC Open 3D tile format using EMT Atlas pipelines, which can then be streamed out in a web. You can create enhanced visualizations through the likes of Unreal. And one of the benefits of being able to handle multiple file types like this is that if you have a broad supply chain with contractors potentially working in different formats, there's no need to worry about converting the files in order to be able to use them within your digital twin. So then moving on to the actual upload itself. So to upload files directly through the UI, you can do this by using the model upload dialog box. And within here, you can select your file as necessary and enter any metadata. So we can apply a specific file name and revision. And if you're intending to upload multiple files that will form a federated scene, you can specify a common scene name, and this means that all models associated with that scene can be loaded concurrently within the viewer. And also, you have the option to select any necessary coordinate referencing systems as well. So for that geospatial referencing that Luke was just mentioning there, it means you can assign your models to the correct coordinate system and have them located as necessary. And if you were to have existing models, then again, you can, and you're not quite sure with the model that you're uploading what system it might belong to, you can refer to a different model and it will inherit that coordinate reference system within the same scene. Yeah, and then moving on to model coordination. So whilst models can be uploaded without geospatial coordination, we obviously recommend that they are, especially when being used for a digital twin, because you can get a lot more from it. And yeah, with Atlas's model viewer being built on Cesium GIS, it delivers responsive 3D visualizations within the web browser. As you can see here, this is a fairly large model that is being visualized here. And this is in fact multiple models that have been federated under the same scene and positioned correctly within the platform. And like I said, large models can be handled. So I think this one was in the gigabytes, which means that such models become available to a wider audience within the project. And this in turn allows for sort of enhanced collaboration around models and how they can be used. So we also offer model commenting and a model review workflow, which I think we'll touch on a bit later on in the webinar. Next up then, so now sort of pulling models into the system. So if we're stepping back to that foundation level, with Atlas being an asset management system at the base, it means beyond being capable of uploading and managing multiple model revisions, assets can also be created within the platform in line with the predefined sort of configuration structure that you would set. So here's an overview of a workflow where we have a model repository integration. We can pull models into Atlas, and then beyond this, we can actually automatically create the associated assets. Or alternatively, the assets can be created separately within the platform and then linked to the models later on. But the key thing is we can relate the two sources of data. And then holding asset records within Atlas allows for information such as unique tag codes to be written back to the model and then fed back to the project to create the golden thread of information. And this workflow as a whole will be another topic that we'll cover in more depth in the future. But this is just an overview today. And then having both sources of data, so the models and the assets and associated attribute data, but it increases the data held in the system. So we've got data-rich models now, and from this you can benefit further in terms of interrogation and looking into the model. So in this example here, we've got some advanced search functionality where we can search the entire model at attribute level. So this is a key benefit, and here we're looking at or returning all the piles that are greater than 18 meters in length, and we can build sort of more detailed search and save those searches so you can reuse them over time within the same model or model revisions for different analysis. Then moving on to model hierarchies. So again, recognizing that you might have models coming in from different supply chain sources. They may not always carry the same hierarchy that you might be familiar with. So what we've built is an ability for users to actually configure their own hierarchy as necessary to view a model. So here we can see that we're identifying 3 key attributes in line with this model, and the user can then update their hierarchy structure settings within the viewer, save that, and once the model's refreshed, then you can see the new hierarchy, which provides a better context for the particular model. So another useful feature, being able to use the data that's actually held within the models in the system. So those are some key things in terms of bringing in 3D models and associated data. So I'll wrap up the design stage now, and I'll pass back to Luke, who will continue with the survey data aspect within Atlas.
Great, thank you, Paul. So survey is a massive source of data when it comes to our projects. So maybe the start of the project will begin with a survey to understand the as is position before you even start the design. And then you're likely to be capturing a huge amount of data throughout the length of a construction project to monitor progress. And then eventually you'll finish with an as-built. And then obviously even into the maintenance phase, you're going to be collecting a huge amount of survey data, whether that be IoT sensors or a variety of different data sets, some of which I've listed here. So this could be visual based surveys, so things like videos and photos. It could be LiDAR, so you're generating your 3D point clouds. It could be, again, open source data such as satellite imagery, or it could be as simple as a field form collecting data and photos directly from site. And anywhere in between as well, thermal, IoT, etc. We're going to focus on a couple of different data sets. So the first being images and videos. So here we can ingest different data coming from different sources. So what would traditionally be siloed data sets, such as this ortho imagery in the bottom. So this is an orthographic picture taken from a helicopter. So nice and accurate in terms of its granularity and its position, but it's obviously lacking some contextual information. We can fill in that gap using forward-facing video. Again, this is going back to our rail example from earlier. And in that video, we can see things like signal ID plates, which you wouldn't get from the vertical view. So again, going back to that geospatial piece, being able to align these two data sets together, you're starting to really enrich your digital twin in terms of the data that is available to your end users. Another crucial data set, which is becoming more prevalent in every project, are point clouds. Point clouds are extremely powerful because they're very accurate and they're providing a full 3D picture of the environment. The problem with point clouds traditionally is that they are extremely data rich. They require specialist software to open and normally quite powerful computing. So because we want to include this data source in our digital twin, we have optimized this processing in a similar way to how Paul described with the 3D models to allow us to stream them directly on the web browser. This becomes really important, especially when we start to overlay huge data sets, such as on our linear assets. So going back to that railway or highway example, here we have potentially hundreds of miles of point cloud. We can dive in at a specific location and it will automatically load the cloud at that position. And as I navigate along, it will load the next chunk in turn. So this becomes a really useful way of accessing what traditionally is quite complex data siloed and having that overlaid into your localized project. Traditionally, point clouds are unstructured data sets. They're millions of individual points, but there's not a huge amount of intelligence behind it. What we want to do is start to link this back to our assets that Paul mentioned. So here in the middle of the scene, you can see a signal which has been detected. And this can be done in a couple of ways. You can either manually segment this and start to create your asset library, or we can use some of the powerful AI capabilities within Atlas to do automated feature extraction. This is where we recognize an asset from a group of points. We'll automatically cluster those points together, classify it, in this case being a signal, and we will create an asset identifier for that specific asset at that location. What we can do now is to start to federate even more of those data sets to get even more intelligent about the assets. So if we take another signal which is identified within the point cloud, because we know its geolocation, we can start to load up other survey data at that same position. So in this case, we can load up a forward-facing video taken from a train survey. What we can do here is gain additional information which isn't present in the point cloud, in this case, the signal ID plate, which we can read from the video frame. And because we now have that ID, we can link it back to the asset in that asset database that Paul mentioned at the start of this call. And we can start to link it to other sources of information within your digital twin, things like documentation, maintenance records, sensor information, etc. So combining that all together, here's a project of a highway scheme. We have some drone information. So this is a series of images captured. We can upload that directly into the Atlas platform, where it will form a photogrammetric point cloud. We can then overlay that with all of the design information that Paul's just been talking about. And we now have an extremely asset-rich digital twin, combining a mixture of geospatial, design, and survey information. So the models within the digital twin still contain all of their native information. They're also linked back to any asset information, and then they're also overlaid with the current state of play based off your survey data. Any IoT sensors that might be in the field can also feed back additional information as well. And this is now really powerful because you have all of your information no longer in separate silos, but all in one platform, regardless of its original source, and regardless of its file type, and regardless of computing power. This is all browser-based. So what does that actually mean? You've now got this fantastic tool. You want to actually start doing things with it. So at a fundamental level, it is a collaboration tool. You're now accessing these data sets, which traditionally a lot of people within your project wouldn't be able to. So a basic functionality here is our collaborative commenting and review workflow. This means that whoever you wish to open this up to, this could be up to your end clients, it could be downstream to your supply chain, it could even be opening up to the public for things like stakeholder engagement. And of course, you can control which data sets are visible to who. This one is showing a commenting process. So this is a great way to gain information and to add a bit of specialist knowledge into these data sets. And again, all of this information is geospatially aligned. So as you access this location, you'll see all of these comments along with the different data sets we've been talking about throughout the webinar. In addition to this, there's a huge amount of data processing and analytics we can build on top. These will all be matters for future webinars, but just to touch upon a couple of them, clash detection and change management. Because we're no longer just looking at a design model in isolation, it's now much more than just your simple clash detection. We can now overlay a survey point cloud, and we can know exactly what the differences are between your initial design and your as-built point cloud. We can also do automated QA QC checks on these different data sets. And by comparing the different data from different tools, we can start to align things with their accuracy, and also doing repeat runs to see what's changed over time. So we're about out of time for the webinar today, so we're going to wrap it up there. Obviously, if you want any more information, please reach out to us. Continue to ask questions in the chat. Or better still, if you want to get your hands on it, we have our free tier available now. So please feel free to scan that QR code on the screen. We're working on providing more guidance documentation, but you should be able to upload your models, your point clouds, your other data sets, and have a little play about some of the things that we've been discussing today. So thank you very much for listening. As mentioned, please drop any other questions in the chat. We'll be sure to answer those, or feel free to reach out to us. Our email address is on the screen now. Thank you very much.